So I wanted to cover three areas today. I'd like to talk a little bit about a new way of thinking about the economy and the building industry, because I think we've been thinking about buildings in a very similar way for a couple hundred years now. Secondly, I'd like to talk about some legacy challenges. I think Laura's already touched on a lot of this, so this will be just a refresher on the same topic. And finally, I'd like to talk about what it means to learn lessons from manufacturing, that you are designing for how you manufacture and how you assemble. Today, architects and engineers are designing for what the end result is. They're not designing for the process required. Okay? So first area, I'm going to jump down to some details so you'll follow what I'm talking about. I'm just going to use the elevator industry as an example. These four companies have a huge share of the global market. Kone's regional, you may know them. These are actually, most all of these are our customers right now. But this is from a report from 2013 from The Economist magazine. And these firms are making something like a 25 to 35% profit margin for operating the elevators in the building. They're making a 10% profit margin to build an elevator and install an elevator in the building. So if you think about that, they don't want to be in the elevator manufacturing business. They want to be in the elevator operation business. But it's a necessary evil to be in the operation business. You have to manufacture them. So they are already thinking about the life cycle use as being the most important thing and not making the elevators as the most important thing. So the other thing that's important is not only is it more profitable to operate, but the revenue from maintenance is much more stable. So if you're a publicly traded company and you can show that you've got so many products out there in use and that you've got services contracts for all of them, you're a much better target for investment. So I'm just jumping down to one system in a building to make sure you get this before I jump back to some ideas in the sharing economy in general. So I think you see these little Lime scooters around Stockholm. You trip over them as you're trying to get through a building. And you may have tried one of them out and found the battery's dead on it. But anyway, this is the idea that you don't own a scooter, you don't own a bicycle. You get one when you need one, and it's you drop it off where you need to drop it off. It's not something that's yours, it's something you're sharing. You know Zipcar, you may know Uber, you know Lyft, you know these different companies. They have different business models. Zipcar's model, I don't know if they're here, I've seen them in the UK and I see them a lot in the US, is that I don't own a car anymore. There's a garage somewhere near my house and there's a bunch of cars in there. There's probably 30 different cars for about 60 people. And so we're sharing these cars and sometimes I might need a truck, sometimes I might need a family van, sometimes I need something smaller. I just get what I need when I need it, and I just put it on the calendar. So I'm paying a portion for having a car. It's not my car. It's a shared car. Get around is the opposite. I have a car. Maybe I have two cars. If I'm an American, I have three cars. And so I have too many cars, so maybe somebody else should use some of my cars. And this company, you just park the car someplace. Someone comes and washes the car. Somebody comes and puts gasoline in the car. Somebody makes sure the cars get used and gets returned to the right location. So now I get paid to have a car. So that's just on the transportation side. And I use those because most people know these kinds of companies, but they don't know as many that are in the building side of the business here. So let me talk about how these other sharing economy industries are starting to impact the construction industry. You guys probably know Airbnb. The other one is Vacation Rentals by Owner. These are two big global companies that you can, instead of going to a hotel, you just stay at somebody's house and you have a room there and you rate them and they rate you, and there's that whole system in place. Well, last year they announced that they're going to start designing their own houses. So in the US, there's a lot of locations where the zoning laws allow you to put a small unit in your backyard. It might be for your parents to come visit or friends to come visit. But other times, Airbnb owns it and operates it as a small hotel in your backyard. So they know all the cities that have this zoning law. They know exactly the right size. They know all the requirements. And now that's a product that somebody delivers on a truck and drops in your backyard, and now gives you a source of income and an extra space you can use yourself. Ali is in London, and I think they're in UK and France, maybe Netherlands. This is an idea that I don't rent the entire apartment. That's more than I need. It's for younger people, millennials. They're graduating from school. They're used to having flatmates that they're sharing a dormitory space in university. So now they're graduating and they're going to the same city. They'd like to stay with some of their friends. They only pay for their bedroom and their bathroom. And then they have maybe 2, 3 roommates, and we share the cost of the kitchen. We share the cost of a living space. We say, do we want to have our own laundry room, or do we want to have the building do a laundry service for us? You decide how much you want, and you pay from a menu. But these services that you get from any of these companies are so much more valuable than the asset by itself. The Collective is, see, Ollie's in Boston and New York. Collective is in London, I know in Paris. So these are new models of how you might manage real estate. I wanted to start here because too often in the construction industry, we keep thinking about how do we reduce cost, how do we control cost. But if you look at this the other way around through the lens the other way, you might say, no, we actually would like to spend a little bit more money on our product because it'll generate better revenue for us. If I'm an elevator operator and I get that big margin from operating those elevators for 30 or 40 years, I want to have less repair. I want to have less problems. I want to have more reliability. I'm willing to spend more on the product. I'm not interested in cutting costs. I'm interested in making the right level of investment because I care about the long-term prospect of the facility. Same thing happening in workspace with WeWork. Google's doing the same sort of thing. They've just signed a big partnership agreement with Lend-Lease to build thousands of units in the San Francisco Bay Area. Google bought Nest, so now they have smoke detectors. They have doorbells and cameras and all kinds of devices to control your thermostat and all sorts. So this is the Internet of Things now. This is not just we're online getting information. Now we've got physical products in the world, in these buildings and in these cars, and that data has high value. So this is about the value of data, what the WeWork company knows about the users of their space. They have a labs group that they lease labs to. They have general office space, a lot of different products. This is about information, this is about services, and this is about the sharing economy. So I took a lot of time on that side. I'm going to go a lot faster going forward. You may be aware of Amazon Go. This is a store in Seattle that my family's been to, and you just walk in, grab what you want, throw it in your bag, and walk out. You know, it knows on your phone that you're an Amazon Prime member. It knows, you know, who you are, and it knows what you picked, and it charges you. And when you walk out the door, your phone goes bing. This is what your cost of your groceries were. And then your refrigerator at home, right? It has a camera inside. It knows what's inside the refrigerator. When you're at the store, it'll turn on and say, oh, you're out of milk. It'll tell you what, you know, you say, oh, maybe, what do I want to make for dinner? This is what I'd like to make. It says, this is what's in the refrigerator. This is what you need to buy. Now your store is smart. Your appliance is smart. This is a customer of ours that makes washing machines. You can see that this person maybe is thinking about, I want to have it washed and dried at a certain time when I get home from work because I like to hang things up and get fresh air, you know. So I want to time it just right. So I just push my phone and it tells me to start up that cycle. So this idea of controlling these devices and these interconnections between the shopping place and the appliances, we need to bring that mentality now to the rest of the building. So what does that look like once it's in a building? Now this is a utility closet. This is a smart electrical panel. This is the gas connection place. The gas here is heating not only the hot water for the building, it's also heating the radiant floor heating system. There's your washer dryer from the last picture in this same system. So now the most expensive parts of the building, the meters, the gas, the power, the water, all of that is in one place, and it's a product. It's just dropped into the building, and you want to upgrade it, you pull out pieces. You want to put in smarter sensors, you do that later. Now you have an operating system to your utility closet, just like with your computer from 30 years ago. Same thing for a bathroom. These bathroom pods, these are now upgradable units that you can change them over time. And you can plug these into existing buildings, so it's not just for new buildings. So we take multiple products and we connect them together. So we talked in the main session and a little earlier about sustainable design. So we've got 30% waste during the construction process, and we are claiming that we are being green buildings and sustainable. Well, we're really not if we waste that much in construction. Buildings are consuming 70% of our electricity. Just reducing that is good, but it's not enough if we waste money during construction. And this gives you a pretty good target. If you look at the impact on lighting, on energy, on heating and cooling systems in a building, you see that just the building envelope by itself, if you productize the enclosure on the building, how much impact you can have. But to do it, you've got to reduce that construction cost to invest in a better system to perform better over time. When we talk about lean manufacturing or lean construction, I think people in the construction industry have a different perspective. This is a survey we did about 5 or 6 years ago with a couple of hundred subcontractors and general contractors in the U.S. market. To net it out for you, I would say that it was only about 7 or 8% of U.S. contractors at that time had actually implemented any true lean system and properly understood what they meant. So these lean practitioners, we asked them about the efficiency in the market. They said 62% of them said it's a really inefficient market, and we know a little bit about it. The non-practitioners, oh no, it's a highly efficient market, 55% of them. So you don't know what you don't know, right? And this is similar to Lars's graph earlier. Mine's more complicated and less informative. But here you have again the economist, 30% waste. But information technology, manufacturing, everybody's getting more efficient, and construction is getting less efficient. And mine's over 60 years, and his is over the past 20. And he's right, that's the dramatic change that he pointed to. So let's jump now to the second section. And this is, I think I presented this 2 years ago, so I'm going to go through it quickly. And I think it overlaps exactly what Lars just covered. These are some of the fundamental problems. Is the architect's documentation, the manufacturer's documentation, the builders are 3 different types of things. This is what it's supposed to be, this is how to make it, and this is the sequence of activity. If we had those, and those were integrated, we still need to connect that information to cost and schedule. The current systems we have, the current BIM tools, are not adequate to that task. If you can't connect these things, you can't create a production control system that's anything like manufacturing. So what does that look like in more detail? These are the BIM products. They are really visualization models. In the background, you see a little bit of simulation for maybe climate analysis or something. And then it just produces 2D drawings. The shop drawings, on the other hand, when you look at a shop drawing model, it better look like the real thing in the field. It's got to be a one-to-one relationship. This is a virtual twin that's being created here. This is just something to produce 2D documents from. And finally, with the sequencing, we need to know about the trucks, the cranes, the laydowns, mobile cranes, tower cranes. We need to know about scaffold. None of that was in these earlier documents, so it all has to be modeled again and added together. To just take it down to a single building element, here's the architect's view of a column. It's the clearances required. Structural engineers, it's a size of a column and a size of a beam without the cladding on the outside. The detailer is yet another party. They have the rebar inside the concrete. The structural engineer does not have that. The builder cares about the formwork. Is it steel? Is it wood? How many pieces? How does it connect? How do I strip it off? The facility manager cares about the composite system. Those are just for structural alone, 5 separate models, 5 different data sets that are not integrated. The second half of this problem is really about trade labor. So again, Lars talked about this, about the difference between doing something on-site and off-site. If you've got a sequence, you've got to wait for, after the structure's done, the plumber comes in and puts slope piping in, then the heating and cooling guys come in and put large duct work in, and then the electrical guys come in and put, so you're sequencing the labor, and everything gets backed up on the job site. So the more that you can go off-site to prefabricate, the better. But then you have to think about on-site execution, you have to think about trucking and logistics and a lot of other problems. But the real opportunity is in the long-term maintenance and operation. I think a lot of companies right now, they're focused on this for the benefit of liability. If you come and fix your own problems, they don't pile up on you. But the opportunity is what I showed you at the beginning, the sharing economy. How can I increase the value of the asset over time? Here's the difference between a factory. I think this might be Tesla on the right, one of our customers. And this is not an unusual site, but these are hand-tying rebar in the field. Which is going to have better quality control, do you think? It's just like Lars showed you with shipbuilding. You've got to have a more automated and better offsite approach. Now, some things you have to do on site, the excavation, sheeting, shoring, tiebacks, that has to be done on site. But you can see the problem right there. They're already, here's all the materials being piled up, and here's all the workers waiting. They can't get down in there until the excavator's done. For scale, you can see there's a worker right there. There's another worker right there. Instead of a concrete truck, this is a high-speed carousel that moves all over this factory floor. This is like a 3D printer that's vibrating concrete into the formwork. You can see finished formwork here that the rebar is exposed on top. So they are setting the form automatically. This table vibrates, and some of these factories, the ones I've been into, they actually load these up into kilns. So instead of 14-day cure time, these are ready to go in about 2-3 days. So less time, higher quality, and more precision control because it's an automated factory setting to try to do these things. A lot of people that talk about having, I want to clarify one of Lars's points. He was talking about modular and offsite. Well, this is modular and this is offsite. But I call this workers indoors because I've got a work team in front of each one of these bathroom pods. And yeah, they don't have on hard hats or steel-toed boots. They don't have on jackets to keep them warm. It's comfortable. The tools are close. It's a safe environment. It reduces job site congestion. There's a lot of benefits to this. But compared to thinking through automation, you're losing an enormous amount of advantage. And here they are dropping the blocks in place at the end. So let's talk about what automation might be like in a factory. I'm just going to focus on concrete for a minute, since it's a simple system to understand, I think. So this is a machine that's spiraling out concrete rebar for concrete columns. And this one's making beams over here. You'll see they're being fed from a spool there, okay? And I'll come back to that in a minute. One of the big reasons you want to go to an automated and factory setting is most geographies that I see around the world today have a skilled labor shortage. Can't get enough electricians, can't get enough plumbers. In an automated factory setting, you can really level out your labor. This factory in the UK that I'm in is looking at 60% labor reduction for their projects, so pretty significant impact. And here those pieces of rebar again that go into that machine are, at a certain gauge, they won't run from a spool and they can't be fed in these machines. So you need to, when you design, you need to understand every station in the factory, the tilting table, the vibration table, the kiln. You need to know every station in the factory, and you need to design for factory capability. Here's a rebar welding machine. Some places, like in Nordic, it's actually tying the rebar instead of welding it. But it's got a certain width that you can produce out of this machine. The machine after this bends it, so you can create certain shapes, but not other shapes. If you don't know the size of the bar, the width of the machine, what can be bent, what can't be bent, then you're designing for the end result. You're not designing for the process. So that's my key point here, is automate more and understand process. Now, this you could do in the field or you could do in the factory, but you might run a series of systems here. I think the red and blue is domestic hot water and cold water. I think the green is a radiant floor heating, and the tan is probably electrical conduit. What I see often is that I showed the rebar being exposed on one of those slabs earlier. They'll lay this out in the factory, take it to the field, pressure test it in the field, and they'll pour the top finished floor on top of it in the field. But now the work of the plumber and the electrician and the heating and cooling people have been done off-site, and all they're doing is testing. Other pieces of equipment are skid-based, those who go into the basement of the building. A lot of factories are trying to decide, do we want to do volumetric or do we want to do panel? I think you actually need to do a little bit of both of those. So here would be a very simple example that I drew up. The length of this piece might be based on the length limit for the truck and turning radiuses. The width might be based on the rebar machine. The thickness might be the crane lift weight, or how many we're going to stack on the truck, or whether it's desirable to pour the topping slab in the field or the factory. But this makes a digital library content, and I think this is a real starting point for most construction companies trying to do modular. You've got to create a content library that understands how to take best advantage of the automated capabilities of the factory, understands the logistics issues. Do I have a place on site to store? Do I have a space near site? Do I have a space near the factory? How much does the truck carry? You'll find that in most countries, the trucking use is different times of day. Sometimes I have to have just certain hours and an escort if it's a long or wide load. Other times I can use it in the middle of the day. So all of those things have to be factored in, the logistics and the factory capability. Okay, finally, the last section I want to get into is this is how we typically design buildings today and have for about 200 years, I guess. We go through this very linear process in which we assume we have all the space requirements from the owner up front. We assume that we have all the requirements for the building code and the zoning up front, and we move forward as if we're never going to go back and change our mind about anything. And we do a series of handoffs. Liability for me as a licensed architect is, ending in some place here. The means and methods is the liability of the contractor. Long-term performance and maintenance is separate liability. So we have these silos of liability, and we have a system today that assumes we move only forward and we never have to go back. I worked in industrial design for a while when I was at Herman Miller, and it's a very different process. We start with the user experience, and we start with saying, how might we want to change it? I wasn't doing furniture at Herman Miller. I was doing office systems. And what we wanted was a rapidly reconfigurable space. That was our objective. And what we would do is do testing with users to see how they wanted to reconfigure the space. So it's anthropology. We're observing current behavior, thinking about a desired behavior, and iterating through a cycle to see how we get to that change in behavior. See how different this is than construction? From that, we have a first iteration of something we might want to physically prototype, and we do some testing about how to make it, what materials. But at some point, we have to get to a production design, something that can be manufactured in large volumes. Here, we would run thousands of units for periods of years sometimes to continue to evolve the design. What I see in the construction industry is people jump right to a factory in which they're spending hundreds of millions of dollars, assuming they know exactly what the product is. That's not the case in other types of manufacturing. If we look at automotive as an example, you can see here that between the fixed standard green parts and the scalable parts in red, that's 80% of a vehicle. And look, you're getting a van, you're getting a sports car, you're getting 4 different vehicles out of this one platform system. Now, if we think about modular in construction, a lot of us think about taking the finished building, chopping it up into chunks and putting on a truck. Obviously, you see that's not what we're doing with cars or airplanes. We're thinking about the supply chain and where the flexibility is really desirable. So these expensive customized pieces, like a sunroof or custom bumpers, they are a way to get a premium price, perhaps. But they're doing this careful balance between modularity of systems, and that's my point about those modular bathrooms and pieces, is we've got to think instead about not chunks of a building, but systems of a building as products. This is where we started. This is where most of us are today, is just coordinating these models. And there's some value to that. But if we can integrate them with the data for cost and schedule, it's higher value to that. If we can do process simulation, both in the field and the factory, higher value still. If we can put in a manufacturing execution control system or production control system, extremely high value. We're still struggling down here as an industry when we need to get up there as fast as possible. And this is what that looks like, that sort of idea of a production engineering system. I'm running out of time, so I'm not going to go through this in detail, but you can see you're simulating the factory, you're simulating the site, and then you're looking at individual worker safety on the job site. This is factories in China. This is a typical automotive factory. And then finally, this is what some of these on-site control as opposed to factory systems look like. And you know, the photograph here in Hong Kong, the photograph here in Vancouver, has got to look almost the exact same as the model. And when you run a time lapse of the actual and a time lapse of this, they should match each other pretty closely. That's not what we get from the tools like Synchro, Vico, Navisworks today. This is a different level of precision. It's something coming from a factory. And it's trying to deal with the issues about, is the worker aligned properly? Are they safe using the ladder on this space properly? Does the tool have access? So we're getting into that level of information, which most of your 4D projects, products in the field don't do today. You're also getting to a whole level of precision about placement of panels or systems that you don't get in the current systems today. Here's an example. This is McGrath that's doing the curtain wall for the US Olympic Museum. And you can see now they have the traditional full-scale mock-up in the field, but here they have a virtual twin of that mock-up. This is really valuable to have both a physical and a virtual model at that level of detail. And here they laser scan the building as it goes, and they can see the guy wires, the temporary safety lines or bracing that might be in the way of installation, and that's coordinated between the virtual and actual. So in summary, I think I'm right at my time limit. These are the 4 takeaways I'd like you to consider. I'm sorry I had to go through this so quickly, but first, I know we all focus on cost reduction, but I think if you're a construction company now thinking about making modular products, you need to think about taking some part of the portfolio and owning it, or creating a company that's a partnership in which you own and operate the facility. Because you'll see that the operations you have and the opportunities you have in a sharing and economy are tremendous. And why would you want to cut costs when you can increase your profit? If you get this 30% margin in operations and you can enhance that, you're going to invest differently. So consider taking some portion of the portfolio and making it something that you actually own and operate, not just show up to repair. Second, you need to productize building systems with the design based on the manufacturer and assembly as the priority, not just the final appearance. And plan for life cycle upgrades. Which pieces of building might we want to pull out or upgrade over time, and how would we go about doing that? That ties back to the first point. These are the real opportunities to get more and more revenue over time and learn more and more about your products. Third, I think it's important that we don't just do workers indoors, but we optimize the automated manufacture of products, and we manage factory throughput. The way that we evaluate things in manufacturing is very different than construction. You're interested in continuous throughput and how quickly you can bring products through a factory as a measure of profitability. That's different than how we handle construction sites. We have them up, we take them down, and when they're down, there's no cost associated with them. It's a different mentality. You've got to connect the two together. And finally, I think we need to refine the building systems and the way we think of them to see about what are the service offerings that are going to go with those products, how will the end user experience them together, value them together, and provide data and feedback over the life cycle.